Hi, welcome to Peace in Math. Binomial expansion refers to multiplying out a binomial raised to a power like this one. You can multiply it out using the distributive property, which is very long and tedious, or you can use the method with Pascal's triangle. Side note, Pascal is not the inventor of this triangle, and it goes by several other names because it was studied hundreds of years before him in places like China, Persia, and India, to name a few. Anyways, the triangle is easy to make so you don't have to memorize it. Start with a baby pyramid of ones, then just start adding to get the numbers below it and put ones on the sides. The pattern continues forever. You're going to want to pay attention to this diagonal because it will tell you which row to use in the problem, so circle it or color it with a highlighter or something. Now let's finally get to some problems. Let's start off with this basic example. We need to expand x plus 3 to the fourth power. So the first thing we're going to do is we're going to look at this exponent 4. Now in the triangle, if we look at the diagonal that we marked earlier, this is where we're going to look for that exponent. So 4 is right here. That means this is the row that we're going to use, this 1, 4, 6, 4, 1. We're going to use those numbers to help us find the coefficients. To help me keep things organized, I'm going to write everything vertically. So I'm going to put 1, 4, 6, 4, 1. And since I'm going to be multiplying, I'm putting parentheses around this. And then for the next part in each of these terms, I'm going to start off with this first term in the binomial, x. And I'm going to raise that to the exponent that we're given, to the fourth power. And then I'm just going to keep going decreasing down until my exponent gets to 0. So it's x cubed, and then x squared, then x to the first power, and then finally x to the 0. And you should always end up 0 to make sure you didn't skip one. And now I'm going to do the second term in the binomial, 3. And this time, instead of starting off with this exponent, I'm going to start off at 0 and increase the exponents. So I'll have 3 to the first power, 3 to the second power, 3 to the third power, and then finally 3 to the fourth power. And now each of these exponents in each row should add up to 4. So here 4 plus 0 gives me 4, 3 plus 1 gives me 4, 2 plus 2 gives me 4, and so on. So my answer, when I expand out this binomial, these are the terms, and they're all just being added. So it's this, plus whatever this comes out to, plus whatever this comes out to, plus this one, and so forth. So I'm just going to write a line here, and I'm going to do the exponents. So I'm going to simplify those. So there's no exponents on these numbers from Pascal's triangle, so that's going to stay the same. 1, 4, 6, 4, 1. I'm going to put my multiplication signs in, and then if I simplify these powers, x to the fourth is just x to the fourth, and then x cubed, x squared, x to the first power is just x, and then x to the 0, anything to the 0 equals 1. And then putting my multiplication signs in, and now for the exponents, the powers of 3. 3 to the 0 gives me 1, 3 to the first power is 3, 3 squared gives me 9, 3 cubed gives me 27, and 3 to the fourth gives me 81. And you can just use the pattern. Since these powers are increasing, just start off with the first one, and then times that by 3, times that by 3, times that by 3, times that by 3, and so on. Alright, so now let's take care of the multiplication. So let's multiply these. 1 times x to the fourth times 1 is just x to the fourth power. 4 times x cubed times 3. If I multiply the integers, 4 times 3 gives me 12. So this line is 12x cubed. The next one, 6 times 9 gives me 54. So that's 54x squared. And then 4 times 27, this will give me 108. So 108x is the next one. And then the last one, 1 times 81, just gives me 81. So this is my answer, x to the fourth plus 12x cubed plus 54x squared and so forth. And I'm just going to write this out horizontally so it looks more like a polynomial. And that's how we expand a binomial using Pascal's triangle. Let's do one a little more difficult step by step. So this time we have 3x minus 2 to the fifth power. Exponent's 5. So if we look at Pascal's triangle, here in the diagonal, 5 shows up in this row. So this is the row we're going to use to get our coefficients. This 1, 5, 10, 10, 5, 1. So let's write those vertically. Alright, now I'm going to take the first term in the binomial, 3x, and I'm going to raise that to this fifth power. And make sure you use parentheses because this 3 also has to get raised to that fifth power. And then we're going to decrease the exponents. So 3x to the fourth, 3x to the third, 3x squared, 3x to the first power, and then finally 3x to the 0. And now I'm going to take the second term in the binomial, this negative 2. Make sure you don't forget that sign that's negative. Negative 2, we're starting off at 0 this time. And then negative 2 to the first power, negative 2 squared, negative 2 cubed, negative 2 to the fourth power, and finally negative 2 to the fifth power. Alright, so here's the terms in our answer. Let's complete the exponents. Let's simplify those. No exponents in the first numbers, so we're going to keep those the same. 1, 5, 10, 10, 5, 1. Putting my multiplication signs in. And then for this next column, I'm going to start off at the bottom this time since that has smaller exponents, so that's going to be easier, and then I'm going to go up. So here, 3x to the 0, anything to the 0 power gives me 1. 3x to the first power is 3x. Here, 3x squared, don't forget to square the 3, so this gives me 9x squared. 3x cubed, that will give me 27x to the third power. 3x to the fourth power, that will give me 81x to the fourth power. And then finally for the last one, 3 to the fifth times 81 by 3, and we get 243 x to the fifth power. I'm going to put in my multiplication signs. And now for the negative 2's, negative 2 to the 0, starting at the top since that has a smaller exponent. Anything to the 0 is 1. And the next one, negative 2 to the first power is just negative 2. Negative 2 squared gives me 4. Negative 2 cubed gives me negative 8. And then negative 2 to the fourth power gives me 16. And then negative 2 to the fifth power gives me negative 32. Notice too, if these end up being like a negative number in the parentheses, your signs will alternate. Positive, negative, positive, negative, positive, negative. All right, so now let's do the multiplication. Okay, 1 times 243 x to the fifth times 1. This gives us 243 x to the fifth power. The next one, 5 times 81 times negative 2. This gives us negative 810 with x to the fourth. The next one, 10 times 27 x cubed times 4. This will give us 1080 x to the third power. And then for the next one, multiplying these out, that gives us negative 720 x squared. Next one, 5 times 3x times 16. This gives us 240x. And then finally the last one, 1 times negative 32, gives us negative 32. And now let's write out all these terms, add them all up together. 243 x to the fifth minus 810 x to the fourth plus 1080 x cubed minus 720 x squared plus 240x minus 32. Geez, look how long that is. And there's our answer. Big polynomial. Now, these types of problems can be kind of a pain in the butt to grade as a teacher, so you might only be asked about one term versus the whole entire expansion. That way, you can demonstrate that you understand the concept without having to work out the whole entire thing. So, for this problem, they want us to find the coefficient of x to the fifth in this expansion, 2x plus 7 to the sixth. So we're going to start to set this up like we did the other problems, but we won't have to do the whole entire thing. So looking at the exponent we have is 6, and let's look for that in the triangle. So in the triangle, in our diagonal row, 6 shows up right here. So this is the row that we're going to be using. This 1, 6, 15, 20, and so forth. So let's start to set up our problem. So if I start to write these, we've got 1, 6, 15, 20, and we can keep going and going and going, but like I said, we're not going to have to do the whole entire thing. And then if I start to set up the first term we have is 2x. So 2x starting off with the exponent to the 6th power, and then 2x to the 5th, and then 2x to the 4th, and I can keep going and going and going. But the term we're interested in is x to the 5th, so that shows up right here. So I don't need to keep going, I'm only going to be interested in this row. So now if I continue the setup, the second term of the binomial 7, starting that with the 0 power, and then increasing the exponent to the first power, 7 squared, and so on and so forth. Alright, so if we start to simplify our exponents like we did in the last one, now like I said, we want x to the 5th, so that shows up right here, so I'm only interested in this row. Doesn't matter what any of the rest is. So I'm just going to simplify this one. 6 doesn't have an exponent, so I'm just going to keep that the same. Here, this 2x to the 5th power. 2 to the 5th power gives me 32, and then there's x to the 5th, and then 7 to the first power is just 7. And now if I simplify, doing the multiplication now that I've done the exponents, if I multiply out 6 times 32 times 7, this is going to give me 1,344, and then x to the 5th. So this term, the second term, which is in our second row, would be this 1,344 x to the 5th. And all we want is the coefficient, so that's the number that our variable is being multiplied by. So then our final answer is just 1,344. Feeling like you need a little extra practice? Here's some more problems for you to try. Take a second, pause the video, and try to work these out on a scrap piece of paper, and then at the end you can check your answers with the worked out solutions. Good luck! Here's the list of the answers to the practice problems. Hopefully this method makes binomial expansion a little bit easier for you, and hopefully this brought a little expansion to your brain. Get it? See you next time.